Welcome to the ABB Hazlux Product Training Series. In the early 20th century, electric power was becoming a major game changer for all industries. With the Industrial Revolution in full swing, electric equipment such as lighting was quickly introduced into coal mines, refineries and chemical plants, which sped up production time. However, it was soon discovered that explosions could be ignited by the equipment itself. Thereafter, various technical standards were developed to identify and classify risk levels for electrical equipment in hazardous locations. In this video, we'll explain how the classification system works and how they can be applied in industrial settings, while also touching on the certifications and ratings we use to make sure our fixtures are 100% safe. Today, lighting and energy standards are adopted by industrial facilities to protect the safety of workers. The National Fire Protection Association, National Electrical Code, and Underwriters Laboratories have a categorization system along with codes that differentiate hazardous areas into classes, divisions, and zones. This way, any electrical equipment, such as our Hazlux products, could easily be selected and installed in the right place. But how can an explosion occur? 3 elements are required for an explosion to occur. Fuel, oxygen, and a heat or ignition source must be present. When placing equipment into hazardous areas, one or more of these factors need to be eliminated to reduce the risk of explosion to a safe and acceptable level. Hazardous locations are defined as areas where fire or explosion hazards may exist due to the combined presence of electrical equipment and flammable gases or vapors, flammable liquids, combustible dusts, or ignitable fibers. These locations are found in a range of industries, from mining operations, aluminum and copper smelting facilities, grain silos, and other manufacturing or industrial sites. The NEC categorizes hazardous locations into 3 broad separate classes: Class 1, Class 2, and Class 3. Class 1 locations are categorized by the presence of flammable gases or vapors in the air. Class 2 locations are listed as areas made hazardous by the presence of combustible dusts. Lastly, Class 3 locations are areas where there are ignitable fibers and flyings. Unlike Class 1 and 2, ignitable fibers and flyings tend to gather on and around machinery and lighting fixtures. If they're not properly handled, a heat source could ignite them. Within the 3 classifications, hazardous lighting locations are further broken down into 2 divisions based on the level of exposure of the hazardous material. Division 1 defines an area in which ignitable concentrations exist under normal operating conditions or where hazard is caused by repair work, frequent maintenance, or frequent equipment failure. Division 2 defines an area in which ignitable concentrations are treated, handled, or used. However, these ignitable concentrations are normally in closed containers or closed systems where they can only get out through accidental rupture or system breakdowns. Falling under the divisions are zones. Zone 0 is an area in which an explosive atmosphere is present continuously for long periods or will frequently occur. Zone 1 is an area in which an explosive atmosphere is likely to occur occasionally in normal operation. It may exist because of repair, maintenance operations, or leakage. Zone 2 is a place in which an explosive atmosphere is not likely to occur in normal operation, but if it does occur, will persist for a short period only. These areas only become hazardous in case of an accident or some unusual operating condition. The NEC code also requires that lighting fixtures for each classification and division be further categorized into groups based on the types, characteristics, and concentrations of materials that may be present. Class 1 locations are subdivided into 4 groups based on the ignition temperature of a substance, explosion pressure, and other flammable properties. Class 1 contains Group A, B, C, and D. Group A generates the highest explosive pressures, acetylene. Group B produces hydrogen, Group C, ethylene, and finally, Group D, gasoline, which generates the lowest explosive pressure. Class 2 is split into 3 groups based on the ignition temperature and the conductivity of the hazardous substance. Class 2 locations are divided into groups E, F, and G. Group E consists of combustible metal dust including aluminum or magnesium. Group F defines an atmosphere containing carbonaceous dusts such as carbon black or charcoal. Group G consists of non-conductive dusts such as flour, starch, wood, plastic, or grain dust. The chemical elements stated in each group are not complete lists of all the categorized materials. The list of substances is longer and includes more chemical compounds, which can be found in our catalog on the ABB Hazlux website. Although zones are approved by the NEC, they are not always accepted by end-user sites. However, there are projects in the US that use zone categorization instead of divisions. In a hazardous area, the maximum surface temperature of an electrical device must not reach the ignition temperature of the potential explosion atmosphere that it operates in. T numbers help ensure the selected lighting fixtures are the maximum allowable temperature for hazardous materials. Our H3 LED offers a wide range of lumen levels for most hazardous locations with varying wattages. If the product is placed in an area with an ambient temperature of 104 degrees Fahrenheit, within a lumen range of 5,000 to 10,000, and the classification of that area is Class 1, Division 2, then the T rating of the product is T5. However, if the same product at the same ambient temperature is classified in a Class 2 environment, the T rating shifts to T6. Depending on the ambient temperature and lumen level, you need a T rating that is suitable for the exact requirements of your project. Correlated color temperature is a Kelvin-based scale used to measure the color temperature of a luminaire. The color chosen for an application will vary based on the space. For example, a warmer light is often used for residential applications, where cool light is more prevalent in commercial and industrial spaces. Warm light is around 2500 K, moving to neutral white at around 3500 K, and to cool white at 5000 K or more. In an industrial setting, all equipment needs to run seamlessly to minimize the risk of workplace hazards. Industry certifications provide users with peace of mind that the products they've selected have met strict safety, performance, and environmental standards. Our Hazlux products are designed to adhere to these standards to create a safe environment, as they meet most North American code for classified areas. Along with the NFPA and Occupational Safety and Health Administration, most of our products are Underwriter Laboratories 844 and some Canadian Standards Association C22.2 number 137 UL certified. Some of our fixtures are also Design Lights Consortium, International Protection Marking, and National Electrical Manufacturers Association, National Sanitation Foundation, and International Dark Sky Association compliant. In the next video, we'll show you our entire Hazlux product offering, provide a comprehensive understanding of each fixture's lighting performance and specs and their applications. For more information about our products, visit our Hazlux website today.